Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2022, 10B, Problem 16, but it can also be found in the 12B, Problem 13. And this week's problem deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states the diagram below shows a rectangle with side lengths 4 and 8 and a square with a side length of 5. 3 vertices of the square lie on 3 different sides of the rectangle as shown. What is the area of the region inside both the square and the rectangle? So essentially we're asked to find the shaded region's area. Well, we can look at some angles right here to see if we can find any similar triangles, because we see that this is a right angle, and then we also know that this is a right angle. I'm just going to label some of the points here. So I'm just going to let this be A, B, C, D, E, F, G. So that'll be much more clear. So we know that angle ABC and angle CDE are both right angles. And then so is angle EFG. And then we know that AC is equal to 5. CE is also equal to 5. And so we would find that angle BAC would be equal to angle DCE. And then angle ACB is equal to angle CED. And then looking at the small triangle EFG right here, angle FEG would be equal to ECD, which is equal to BAC, and then FGE is equal to the other corresponding angle. So after we have this figured out, we know that all 3 of these triangles are similar triangles. And then looking at what we are given, we know that the side length of the rectangle is 4 and 8, and then the square has a side length of 5. So that means that this would be 4, AB would be 4. We already know that AC is 5 because of the square, and we know that it's a right angle, so that means that BC must be 3 because it is a 3, 4, 5 triangle, right triangle. So that's just like a triple that we should know. That's like one of the most basic triples for right triangles. And then because AB is 4, then that means that CD is also 4. And so that gives us ED is 3. So these 2 triangles are the same triangle. They have the same side length, and so that means that they have the same area. However, EFG is only similar to ABC and CDE, but obviously it is a lot smaller. Looking at the lengths again, we know that FD is 4. And then we also just figured out that ED is 3. So that means that FE would be 1. But now we need to use our knowledge on what we know of similar triangles, because ultimately we're trying to find out the area of the shaded region. So we know the area of the whole rectangle, and then we can subtract the areas of the triangles. Well, we already know the area of the triangle ABC and CDE because we know all of their side lengths. However, for the smaller right triangle EFG, we could go and try to figure out the other side lengths. But we should also know that if 2 triangles are similar, and if we know the ratio of the sides, then that means that the ratio of their areas is the square of the ratio of the sides. So essentially, if we have FE over AB, we know that that's the ratio of the side lengths, which is 1 over 4. Well, then the ratio of the areas, like I just said, is the square of the ratio of their sides. So that means the ratio of the area would be this squared, which is 1 over 16. And then so we have that the area of triangle EFG over the area of the triangle ABC, which we know is base times height divided by 2, which is 3 times 4, 12, divided by 2 is 6, over 6 is equal to 1 over 16. And then so we can cross multiply. To get the area of triangle EFG is equal to 6 over 16, and that can be reduced to 3 over 8. So that is a lot quicker than going and trying to find out the ratios of the sides, which we know, and then trying to plug that in to find each of the lengths of triangle EFG. So now we know that the area of triangle EFG is 30 over 8. And then like I just said, the area of triangle ABC and CDE would be 6. Okay, so now that we know the areas of the triangles, we can figure out the area of the whole rectangle, ABDF. So it would be 7 times 4, not 8, because 8 represents this whole length. It's the side length of the whole rectangle, but then there's also this part that we need to account for. So we know that BC is 3, CD is 4. So that means that BD, the length of the rectangle that we want, the smaller rectangle, would be 7. And then the height, or the width, is still the same, 4. So 7 times 4 minus the area of the triangle, 6 plus 6 plus 3 over 8. Okay, and then quickly solving that, we get it to be equal to 15 and 5/8. So the answer is D.